So here we are starting day 2 of Law of Cosines. You'll see that the homework for today is just the same problems as I gave you yesterday, but there is a Schoology quiz. And by the end of the hour, you'll be working with your partner on the Schoology quiz. If you ever finish a problem that I give you today and you've got extra time, I suggest you and your partner start the Schoology quiz together and then okay, well, everybody else is finishing this and we're already done. Let's get a problem done of the Schoology quiz. So you can be beating your way through that Schoology quiz so you don't have as much homework tonight, because that's your homework, is that Schoology quiz. All right, so look at this one. This is the first one I'm giving you as a group. This is your top priority. Don't go do the Schoology quiz till you're done with this. I think you would need to find the height first, because do you remember that deal where if your side length is not even that long, then the triangle doesn't exist. You got to figure out what that blue height is. Then let's say that blue height turns out to be like 7. Well, then 6 wasn't even possible. Jack, are you on a phone? Okay, good. All right, so that blue height is really important. And once I know that blue height, and let's say it is 7, then the sides between 7 and 10 would be the ones where it's indeterminate and it can swing in both directions. All right, so the first thing you have to do is figure out that height. That makes a right triangle. I'll make a blue dotted line here. This right triangle has 3 pieces of information. It says 33 here, 10 here, and it's a right triangle. So you've got to do right triangle trig, and then you're going to use law of sines in a minute, because in the end you got to figure out the measure of side A, which, by the way, I just want you to do this one. I know there's 2 ways you could say the side is. We're just going to find the smaller one. That's side A. But you can't start with that. That is not what you start with. What you start with is finding the height. I'm going to make it the dotted red and blue line there. All right, work with your partner to figure out problem 1 and 2. Pausing while you give that a shot. So we just got done talking about inflation there to help kids understand that's a real world thing they're experiencing and how that actually works. You'd need a whole 1-year course called Econ 101 to understand that better. But did you figure out how tall this thing was? Jack, what did you guys get for that height? 5.45. Does that mean that this 6-inch one actually would have to swing in 2 different directions? Was there 2 different triangles? Because the whole point of the question was, prove it has 2 possible triangles. And yeah, it does. Because this is 6 is bigger than 5.5, but less than 10. If it's in that zone between 5.5 and 10, those numbers will give you 2 triangles. Then you guys figured out this angle. I know you had to. But to do that, you had to figure out this angle. And I remember this is 50 point something. Somebody help me out. What was it? 50 something? No. 60? Okay. 65 point what? Can anybody verify 65.01? That feels wrong to me. Okay, then that's not right. Okay, so what was that angle right there? All right, I'm going to remind you how to do it, because if I have one group saying an answer and it's wrong and no other group's willing to volunteer, then my sense is that you didn't do that right. So listen, please, to some groups that are talking. Don't talk right now. All right, so this is angle B. So I'm going to go sine of big B. You always start with your variable. Over the side across from that, which is 10, equals, and these are 2 that we know work. It says 33 goes across from 6. Sine 33 over 6. Then I'm going to times both sides by 10 to clear this fraction. And then I've got a number here. If you haven't already, you and your partner figure out what this is right now. Use your calculators. Pausing. Okay, this came out to point something, because sine of B equals point something. Alex, calling on your group. Point what? 9. I agree. 907. I'm going to leave it actually longer. Why? Because the more you round it, the further off you get. Now, it might not make much of a difference, but I'm going to use that. Then I'm going to do inverse sine on both sides, because the inverse sine cancels off sine. And now I have b equals inverse sine of, I use second answer to bring that down in the calculator, and I get 65.19. It was right. 65.19 is what this angle was right here. And nobody was willing to confirm it, so we had to do it together. Then if that's 65.9, this is 65.9. And if that's, or 19, sorry, that's quite different. 65.19, I'm going to round it to 65.2. And then I'm going to subtract it from 180. Why am I subtracting from 180? Because these two together add up to 180. So then this one must be 114.8. Anybody verify 114.8? Cool. Then, why do we do all of that? Eventually, you got to get this angle up at the top. I'm going to color them and see if you get this. This angle and this angle and this angle have to add up to 180. So now I'm going to take 180 minus 33 minus 114.8, and I get 32 for this angle way up here. Did anybody get to that before me? 32 degrees up there. Good. Now I'm ready to set up one last law of sines. Remember, the goal was to find A. So I start with A. A over sine of 32. And that goes with the other combo we had was the 33 and the 6. Okay. So I'm going to go with 6 over sine 33. And then that is just you and a calculator and doing some multiplying. 6 times sine 32 all over sine 33. Would you check that right now to make sure you like your answer? Because I'm going to call on a different group to get the final answer here. What'd you guys get?
5.837.
5.837. I'm going to round to 84. They'll tell you what to round to on the test. How many of you guys had that before I did? Okay, now if you didn't have that, you don't know how to use that law of sines terribly well. Remember, the test isn't for a while. We've got some time, but this is not something we can keep doing every day. I've done this problem multiple times. Yes?
Like, if you were like 2/10 off or something, would you still get credit? Or?
You would lose partial credit if you round to the wrong, if you're slightly off in your rounding, but you'd get most of the points. Now, in this case, I'm not even saying that mine is perfect. Yours might be more accurate than mine. How can you win in the accuracy contest with the teacher? If you keep your decimal less rounded, as in you keep more decimal places in your answer all the way to the end, and only at the very end you round it. So that's the moral of the story. Kids round too early. If you round a lot early, you're going to be off at the end. You want to wait to the very end, and only at the very end, then you can round it to what place they tell you to round it. All right, so moral of the story, I could even be off a little bit right now. So maybe yours is more accurate than mine. Did you include more decimal places or less than me? That's what you have to ask yourself. I included more decimals, so I'm more accurate. So you could be off. All right. I want to get to one law of cosines question. And I first want to ask you, if I had sides that were a right triangle, would I even be using law of cosines? No. Law of cosines doesn't really help you on things that are right triangles. But if I make a triangle, would you please make a triangle that where the sides are very close to equal to each other? That's called an equilateral. We're not making it exactly equal, or they'd all be the same, and then it's super easy. Make the sides where it's really close to the same lengths as each other. Then, whatever you perceive as your smallest of your sides, call it 8. I think this is the smallest of my sides. Whatever you perceive as the second biggest side, call it 9. And then whatever you feel like is your biggest side, call it 10. It depends on your triangle, but like 1, 8, 1, 9, and 1, 10. And if you had 3 sticks that were all 8, 9, and 10 centimeters, it's really hard to tell them apart unless you lay them out down right next to each other. So as long as you made them kind of close, your eyes will believe it. Now I want to know what the angle between the 9 and the 10 is. That angle right there. Now, would the law of sines do this for you? No. The law of sines, you need an angle and a side across from it. Would the law of cosines do it for you? Yes. Be very careful, and you and your partner together do a squared plus b squared minus 2ab cosine of big C equals little c squared. And you'll have to do inverse cosine at the end to find that angle. All right, I'm going to pause for a minute. Do this thoroughly and carefully and check you and your partner's work along the way. Don't just wait to the end and have different answers. Get like, are you subtracting 114 from both sides? You know, ask them along the way. All right, I'm going to pause while you guys try this one. Super important. Were you guys smart enough to know that this was C because it was the key angle? If you didn't pick that to be C, the problem would have been very hard, twice as hard. I'm going to pick this as A and this is B. You could have switched those around, but the C is the key angle. Now, it's the way I picked it. A was 9. Would it matter? No. A and B don't matter. C matters a lot. I'm showing the work just so that those at home might, let's see here, it's 8, might understand where their mistake was.
Mr. Server, you made B 8 by mistake.
Oh, thank you, thank you. That would have cost me. B was 10, so wherever I have an 8, rats, I'm gonna need to make it a 10. Thank you. Now I'm going to do inverse cosine at the end. Inverse cosine on both sides. I'm rounding, maybe different than you, but I got 49.5 degrees. Raise your hand if your group got 49.5 degrees. Okay, good. That's how you use the law of cosines. When do you use the law of cosines? It's simple. Whenever you can't use the law of sines. Well, when can you use the law of sines? When you have a side and an angle across from each other, and you know those two things, like if I know this is 5 degrees, and I know that side is 20, then I'm instantly thinking law of sines. Whenever I don't have that set up, and I don't have the side across from my angle, and this is 5, maybe this is 5 and this is 6, then I'm thinking law of cosines. But FYI, law of cosines can usually work in either kind of problem. So if you get good at law of cosines, and you have it memorized, and you know how to work it, you can do pretty much half the test we are coming up here with the law of cosines. It's just that the law of sines is twice as fast. So use the law of sines when you can. Okay, so you have a Schoology quiz. That's your homework for tonight. And the rest of the time should be you and your partner fighting through those. Those are tougher questions, but hey, that's what the test is like. It's not like these are ridiculously hard. These are about the same difficulty level as your test that's upcoming. So work through it with your partner. And the Schoology quiz is your assignment for tonight.